Alright students, in this lesson we are graphing quadratic functions. The general form of a quadratic function is f of x is equal to ax squared plus bx plus c. Just recall that f of x is just another way to say y. So f of x right here is just another way to say y. And we know this is a quadratic function just because the exponent next to the x is more than 1. It's a 2. That's how we know it's quadratic. Just really quick, so the quadratic function, obviously it's not a linear function, it's not a line. This one has its unique graph. It either opens up, that's what we call a parabola. It opens up when the value, the coefficient next to the x squared, is more than 0. And it opens downward, the parabola opens downward when a is less than 0. Alright guys, so typically when it opens downward, if it opens downward, then we know it has a minimum point. We call that a minimum. If it opens downward, it has a maximum point. So whether it's a minimum or a maximum, this point is called the vertex. And what we find that vertex, it's going to be an ordered pair. It's this formula, negative b over 2a, comma, whatever this value is, you substitute it back into the function. You plug it back into the function and you will get your vertex. That's either going to be the minimum or the maximum. Another key feature of a parabola is something that we call the axis of symmetry. The axis of symmetry, it's a vertical line that breaks or partitions the graph, the parabola, right in the middle, right through the center. This line here, we call that the axis of symmetry. And the axis of symmetry, it's always going to be a vertical line. It's always going to be x equals a number. Remember that? X equals a number. And it's always going to be the value of the x, or the x value of the vertex. This, whatever that is, this will be the axis of symmetry. Okay, that's going to go into partition. That's going to partition the parabola right in the middle. And the last key feature here that we need to consider of a quadratic function is the number by itself. This number by itself, we call the constant. This is always going to be the y-intercept. Always the y-intercept. So let's consider all that and let's graph a quadratic function. So let's clear this and let's look at this function here. So we have f of x is equal to x squared plus 6x plus 8. So first thing I need to know is, does it open up or down? And this one here, well, because the coefficient or the number next to the x squared is positive, we know this opens up. So we know it's going to open up. That means it's going to have a minimum. So let's find the minimum. It's going to be negative b over 2a. Remember, this is a formula. Negative b over 2a. We substitute that back into the function to get the y value. So we have negative b, so we got a, b, and c. A is 1, b is 6, and c is 8. So we consider that. Then we have negative 6 over 2 times 1, which is equal to negative 6 over 2, which we know is negative 3. So the vertex x value has a value of -3. To find the y value, what you do is just simply take this value, which is -3, and substitute it back into the function there and here. So we have -3 squared plus 6 times -3 plus 8. And all we do now is we evaluate this, simplify it. -3 squared is 9 minus 18 plus 8. This becomes -9 plus 8. It becomes -1. So now I have the vertex. The vertex is -3, -1. And we already have it here, -3, -1 right there. That's going to be the vertex. This is the minimum. This is the lowest point. All right. So next, let's consider the axis of symmetry. Axis of symmetry. Remember, it's always going to be x equals whatever the x value of the vertex is, -3. That means we have a vertical line. This vertical line right here is, or it will cut the parabola or the graph right in the middle. All right, and another key feature here is the y-intercept. What is the y-intercept? The y-intercept is always the number by itself, so it's going to be 8. All right, 1, 2, 3, 4, 5, 6, 7, 8. So there you go. Now, remember that this axis of symmetry is right in the middle of the graph. So if I go to the right 1, 2, 3, I can go to the left 1, 2, 3, and I have now 3 points. I have enough points to complete the graph, complete this function. So we know it's going to open up. It's going to go this way, right through the y-intercept, of course, and it goes this way forever. Okay, that's one way we can find those points. Another way is you can make a table. If you make a table, for example, you know that the center is going to have an x value of -3. And we know it's going to be -1. Well, take a value to the left of -3, for example, -4, and a value to the right of -3, which is -2. Plug those in, and you will get two other ordered pairs, and that should allow you to complete the parabola. But I think the easiest way to graph this is using the y-intercept, count the units to the axis of symmetry, and then just flip that to the left. All right, I hope that makes sense. Really quick before I forget, when we look at the domain here, the domain, remember all the x values, where does the graph exist on the x-axis? And we're going to say everywhere on the x-axis. If I consider the range, where does the graph exist on the y-axis? And we're going to say it's going to be above or equal to -1. So y is greater than or equal to -1. So that's the domain, and that is the range. All right, I hope that makes sense. The next thing I need to go over, and I know this is a very extensive lesson, is the rate of change. So rate of change, guys, is just another way to say slope at a particular point. Sometimes we call that derivative. So just really quick, rate of change. Rate of change. And again, rate of change is just the slope. And we know that the slope is found by using this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When we look at the rate of change, we have this formula. It's the same thing. It's f of b minus f of a all over b minus a. And it's the same idea as this over here. We have 2 points. We have point A we have point B. To get the y value, we just take point B, plug it into the function. To get this value, y value, we take A, plug it into the function. So this is looking at a particular point of a graph. Typically, when we look at slope, we look at slope in terms of a linear function, but when we look at rate of change, it's more like a point, a specific point. And so let's consider a quadratic function where we have to find the rate of change. All right, so for example, if I have this equation here, and let's consider this equation and let's maximize it. So let's have this equation here. Find the rate of change from point -4 to 4. All right, so let's consider this right here. Well, from point -4 to 4, that's where we have the A and the B values. So we have the A is the A value is -4 and the B value is 4. So we do, on the bottom it's simple, it's going to be B minus A, which I guess in this case is 4, -4. And so that is equal to simply 8. And then on top we have f of b. Well, f of b is 4, so you take 4 and we substitute it into the function right there. So we have 4 squared minus 10 times 4 plus 5. Well, that's going to be 16 minus 40 plus 5. 16 minus 40 is going to be -24 plus 5, -19. All right, so we got this part done, -19. Now we have minus. Let's do f of a. F of a, well, a is -4. Take -4, and again, take -4 and substitute that -4 into the x there and to the x here. So it's going to be -4 squared minus 10 times -4 plus 5. -4 squared is going to be 16 plus 40 plus 5. So we have 16 plus 40, it's going to be 56 plus 5, 61. All right, so we have -19 minus 61. That's equal to -80 over 8, and we get -10. So the rate of change for this function here from -4 to 4 is -10. I know I did that a little quick, but pause it, go back, check it out. Let me know if you have any questions. Thank you.